Okay, in this video, we're going to be solving some linear equations, some absolute value equations, all things that we've done in the past, just a reminder of how to do them. Okay, solving linear equations, we're trying to get our variable by itself. Now this process, again, it's just got some simple steps. Let's remove any parentheses we have, combine some like terms, move your variables to one side, move your numbers to the other side, and then solve from there. So step number one, let's get rid of our parentheses. So everything else stays. 39 minus 5k equals 1. We're going to distribute negative 8. Negative 8 times negative 8 is a positive 64. Negative 8 times a negative 1 would be a positive 8k. If you have any like terms on the same side, put them together. 39 minus 5k, nothing like on this side of the equal sign. However, 1 and 64 can be combined into 65 plus 8k. Next step, we're going to move our variables to one side, and we're going to move anything that doesn't have a variable to the other side. So it's minus 5k. We're going to move over here to the opposite side by doing the opposite operation. Minus 5k turns into a positive 5k. Mark it out. If we're going to move our k's to the right, let's take our 65 and move it to the left by doing minus 65, the opposite. You now have negative 26 is equal to 13k, and then we're just solving from there. 13 times something, to get rid of it, we're going to divide by 13, and we find out that negative 26 divided by 13 is negative 2, so that's your value of k. That can always be substituted back into the original to check and see if it's right. Now, anytime you have a whole side being divided by something, you really need to take care of that first, and there's two ways of doing it. You could use distributive property by dividing everything by negative 7, which wouldn't be a problem here. However, this would end up with a decimal fraction, so let's do it the other way. To get rid of divided by negative 7, we can mark it out and come over here and multiply by negative 7. We can just distribute a property there. So the 4y minus 7 is now by itself. Negative 7 times both of these would be negative 7 plus 42y. Move all your y's to the same side. It doesn't matter which one you move. We'll just move the plus 42 by doing minus 42y's. If you're going to move your y's to the left, let's move our numbers to the right. So mark out minus 7 and add 7. Equal sign is in the middle. 4 minus 42 is a negative 38y. Negative 7 and positive 7 is 0. Last step, do it one of two ways. Either ask yourself, negative 38 times what is 0? Or mark it out and actually divide by negative 38. You get y is 0. Number 3. Distributive property, 4/3 times 9 and 4/3 times 51. If you need to come over to the side and do 4/3 times 9, cross cancel, 1, 3, that gives you 12. And 4/3 times 51, cross cancel, 1 and 17, that gives you a minus 68. 7w, distribute this negative 1. Negative 1 times 68 is a negative 68. Negative times negative is a positive 5w. Combine all your like terms. You now have 12w minus 68 equals 7 and 5 gives you 12w minus 68. So oddly enough, you have the same thing on both sides. And when you do, this happens. When you move your 12w by subtracting and you move your minus 68 by adding, you end up with 0 equals 0. No more w's. Anytime your w's cancel, your variables cancel, and it leaves you with a true statement. This is infinite solutions, which means I could plug in any number into my original problem and it's going to be an answer. It's going to look like it's a solution. So therefore, that's all you have to do. If this had come up to be a false statement, then your answer would have been no solution. So either infinite solutions or no solutions whenever your variables cancel. Okay, next up. Again, distributive property, 3x minus or plus 11 minus x equals 3/2 times 4/3. 3's cancel. 2 and 4 leaves you with a 1 and a 2. So that's going to leave you with 2x. 3/2 times 12. 2 and 12 cancel, leaves you with 1 and 6. So that'd be a plus 18. Combine all your like terms. 3x minus x gives you 2x plus 11. And then on the right side, you have 2x plus 25. And the same thing, what I just described is about to happen. Move your 2x's by subtracting. Move your 11 by subtracting. Gives you 0, because all of this is gone, is equal to 14, which is a false statement. Anytime you come up with a false statement, this equation has no solution. Next up, we're going to be dealing with literal equations, and a literal equations is just another name for a formula. Okay, kind of like y equals mx plus b, e equals mc squared. We're going to be solving this for a certain variable. So like here, we're trying to get our j by itself. First off, I would get rid of this fraction. The way we're going to get rid of this fraction is to mark it out. Since it's divided by, let's multiply. Move it to this other side by multiplying. 3j. 6 times 3 is 18, and I'm going to put them in order, jk. Now to get j by itself, I've got to move these two things. Since they are being multiplied, I can move them at the same time by dividing. I'm going to divide by 18 and divide by k, mark them out, and j is now by itself. Let's clean it up a little bit though. J is equal to 8 over 18, we can reduce to 4/9. H on top, k on bottom, they do not combine. Next one. Number 6, we're trying to solve this thing for B1, getting this by itself. So first thing you can do, you could actually get rid of both of these. Reason why, they're both being multiplied by the whole side, especially the 1/2. I really like to get rid of that 1/2 first. To move 1/2, since it's being multiplied, we're going to have to divide by 1/2. If you remember correctly, to divide by fractions, you flip and you multiply. So we're actually going to be multiplying by 2. So you can mark this out, come over to the other side, and simply multiply by 2. So it equals h times b1 plus b2. Okay, again, you could have distributed, but I don't like to, just because h is being multiplied by everything, so you could actually go ahead and just get rid of it by dividing by h. So you now have 2a over h equals b1 plus b2. And we're trying to get b1 by itself, so now it's just getting rid of plus b2. And to do that, since it's a plus b2, we just got to come over here and do minus b2 to the other side. So now b1's by itself. b1 is equal to 2a over h minus b2. Now you could have distributed there. It would have been a little bit uglier. I would have definitely still moved my 1/2 over first, but you could have distributed and done some stuff, but I think that's going to be the easiest way to work that problem. Next step, we're trying to get y by itself. Now this one's a little tricky because you have a y squared. So we're going to move our 3x over first. You can go ahead and do that without even recopying the problem. And we're going to move our 4 over. Since it's being multiplied, we're going to divide. So we now have y squared equals 7z minus 3x over 4. To get rid of a square, we square root the other side. But we always put a plus and minus symbol in front of it when we do. So now y is by itself. Now one thing we could do to clean this up though, square roots can be split. The square root of a fraction, like the square root of 9/16, could be split into the square root of 9 over the square root of 16. You can do the same thing here because the bottom numbers are 4, and we actually know the square root of 4, so we could actually write this as plus and minus the square root of the top, 7z minus 3x, over the square root of 4, which is just plain 2. So you could remove that radical on bottom. Number 8, we're trying to get m by itself. Problem is there's 2 different m's. So anytime you have multiple, like a lot of the same variable, here's your steps. Always get them together. So we're going to take our m in, and over there with it, I'm going to move this 2m, so minus 2m. If it doesn't have an m, move it to the other side, equals p. So here's what you do now. Now that you've got them all on the same side, if you factor, you go from having 2 of them to 1 of them. So we're going to get them on the same side, factor it out. Now that these are being multiplied, we can get rid of this by dividing. So we have m is equal to p divided by n minus 2. Okay, finally we're going to be solving absolute value equations. Now they've done you a favor up top by actually giving you the steps. Recall, to solve an absolute value equation, we isolate the inequality. That should actually say isolate the absolute value. Step number 2, create 2 different cases, and step number 3, we're going to solve both cases. So get the absolute value by itself, which here it's already by itself. We're going to split it into 2 cases. We're going to say that the stuff inside is either equal to 98 or the stuff inside is equal to a negative 98, and simply solve both of those. To go to minus 2, we're going to add 2, and you can actually solve them simultaneously because it's going to be the exact same steps. You have negative 10w equals 100, and over here you have negative 10w equals negative 96. Divide them both by negative 10. Mark them out. Gives you w is either equal to negative 10 or w is equal to, okay, negative divided by negative is a positive. 96 divided by 10. A couple of different ways you can write this. You could actually divide it. You get 9.6. Or you can reduce the fraction. Let's see, divide top and bottom by 4. That's going to be 20, or divide top and bottom by 2. I think it's going to be the greatest common factor. That'd be 48 over 5, which is the exact same thing as 9.6. Now, sometimes you will have what's called extraneous values. It says check for extraneous values. You only have to check for extraneous values. This is my word of advice. You won't find this in many books. Here's your key. You'll only have extraneous values when you have variables outside of the absolute value bar. So number 4, we'll have to check. Number 15, there's an n outside the absolute value bars, and 16. That's the ones you need to be checking for extraneous values. So we don't really have to worry about this one on number 9. Okay, number 10, isolate your absolute value. Let's move minus 6 over. You now have the absolute value of 2b plus 4 equals plus 6 gives you 20. We split it. The stuff on the inside set it equal to positive 20. The stuff on the inside set it equal to negative 20. Solve both. We're going to move our plus 4 over by subtracting 4. That gives you 2b is 16, and 2b is negative 20 minus 4 is negative 24. Finally, we're going to divide by 2, gives you b is 8, or b is negative 12. Two different answers. Number 11. Again, you're going to isolate absolute value first. The way we're going to do that, since you have times negative 4, mark it out and divide the other side by negative 4. Split it into two scenarios. 7, the stuff on the inside is equal to 9. The stuff on the inside equals negative 9. Solve. Now, again, the way I like to solve it when you have a negative a or a negative variable, I like to move that over and move the 9 to this side. So negative a becomes a positive a. And to move a positive 9, you have to subtract 9. That would give you 7 minus 9 is negative 2. Same thing here. Move the a over by making it a positive a. To get rid of negative 9, I'm going to add 9, which would be 16. So those are two different answers. Here, to isolate the absolute value, you have a couple of steps. To get rid of negative 9, I got to add 9, so that'd be negative 34 equals 2 times the absolute value of 6 plus 8k. Then I have to divide by 2, and that gives me negative 17 equals the absolute value of 6 plus 8k. And I actually don't have to go any further. If you take the absolute value of anything, you will always get a positive value. So if you ever have the absolute value is equal to a negative number, how can you take the absolute value, because absolute value makes things positive, to give you negative 17? You can't. There will be no solution to this, so you can actually stop there with that step. Number 13. Two things to move over. Let's move the 1 over first. You now have negative 10 times the absolute value of 9r plus 3 equals negative 30. Dividing by negative 10 gives you the absolute value is equal to 3, which is legal. Okay. Now up here you had absolute value times something equal to a negative. So you have to completely isolate, and that's why. Split it. 9r plus 3 is 3. 9r plus 3 is negative 3. Move the plus 3 by subtracting 3. You now have 9r is 0, or 9r is negative 6. Divide by 9 gives you r is 0, or dividing by 9 here, let's reduce that fraction, gives you r is negative. Divide by 3, 2 and a 3. So r is 0, or r is negative 2/3. Now again, starting with 14, I'm going to have to check for extraneous values. Anytime you have variables on the outside, some of your answers might not actually work, even though it looks like they're going to. So this is isolated, so let's split it. 5a plus 8 is equal to 3a minus 10. 5a plus 8 is equal to, now when you take the negative of this, make sure you negative both. Negative 3a and a positive 10. Solve each. Let's move our 3a by subtracting, gives you 2a. If you're going to move your a's to the left, let's move our 8 to the right. That'd be negative 18, and you get a is negative 9. And I already see a problem with that. Move minus 3a by adding, that gives you 8a. Move your 8 by subtracting, that gives you 2. Divide by 8, and you get a is 2/8, which we can reduce to 1/4. Now, that looks like our two answers, but again, I already see a problem with negative 9. Remember what I told you, when you take the absolute value of something, it's always got to equal a positive value. Well, look what happens when you plug your negative 9 in right here. Okay, to check for extraneous values, you've got to plug in each of these one at a time to see if they work. When you plug in negative 9, right here and right here, it gives you the absolute value of negative 45 plus 8, which is negative 37, is equal to 3 times negative 9 is negative 27 minus 10 is negative 37. The absolute value cannot equal a negative. The absolute value of negative 37 is 37, not negative 37. This is an extraneous solution. We do the same thing with 1/4 just to check it, because there's a possibility we might not have any answers. 5 times 1/4 is 5/4. We got to add 8. Common denominator, multiply top and bottom by 4, gives me a 4 on bottom, gives me a 32 on top. That would be 37/4. 3 times 1/4 is 3/4. Let's come over here, 3/4. And I've got to subtract 10. So we multiply top and bottom by 4. That'd be 40/4, which 3 minus 40 would be a negative 37/4, which is also not a true statement. So therefore, this is rare, but you actually had two extraneous solutions. There are no solutions to this absolute value equation. Number 15. Again, we first isolate the absolute value, so move the minus 5 over by adding 5. And we can just start from there. The absolute value is isolated, so now we split it. 6n minus 7 is 3n plus 5. 6n minus 7 is equal to the opposite of it, which would be negative 3n minus 5. Minus 5. Let's move our 3n's by subtracting. 6n minus 3n leaves you with 3n's. Move our minus 7 by adding. That gives you 12. Divide by 3 gives you 4. Move your minus 3n by adding. You now have 9n. Move your minus 7 by adding. It's equal to 2. Negative 5 plus 7 is 2. To get rid of 9, let's divide by 2. And again, you got n is 2/9. Let's check for extraneous solutions. Go back to your original. Let's do it from our original. Go back to the original problem. 24 minus 7 is 17. The absolute value of 17 minus 5 is equal to 3 times 4 is 12. The absolute value of 17 is 17 minus 5 gives you 12. That checks out. This is a solution. Do the same thing with 2/9. You have 6 times 2/9. Let's come over here. 6/1 times 2/9. Cross cancel. Leaves you with a 2 and a 3. That'd be 4/3. And we have to subtract 7. Let me do a different color so we can keep track of it. So you have to 4/3 minus 7/1. Common denominator, multiply top and bottom by 3. That's 21/3. So that's going to be negative. Inside the absolute value bar is negative 17/3 minus 5 equals 3 times 2/9. 3/1 times 2/9. Cross cancel. 1, 3. That gives you 2/3. So we have to do the absolute value of negative 17/3, which is 17/3. We have to subtract 5 and see if it's equal to 2/3. Multiply top and bottom by 3. That'll be 15/3. When we do that, 17/3 minus 15/3 actually does give you 2/3. So that's also a solution. So both of those solutions did work. So that just goes to show you don't always have to have extraneous solutions. Okay, next one, we got to get rid of 1/5. You can divide by 1/5, which is the same thing as multiplying by 5. Flip and multiply. So we're going to do 5x plus 25. We split it. Gives you 6x minus 1 equals 5x plus 25. Or 6x minus 1 equals negative 5x minus 25. Move the 5x by subtracting gives you 1x. Move the minus 1 by adding gives you 26. Move the minus 5x by adding gives you 11x. Move the minus 1 by adding gives you negative 24. Divide by 11, and that's your second solution. X is negative 24/11. Again, we have to plug them both in to see if they work. We'll start with 26, and we'll do the original. So 6 times 26 is 116 minus 1 is 115. So 1/6 times the absolute value of 115. Does that equal 26 plus 5, which is 31? Or that's supposed to be 1/5, excuse me. The absolute value of 115 is 115. When you take 1/5 of that, you get 31, so that one checks out. Try your second one. So we got to do 6 times negative 24 11ths, or negative 24 11ths. Nothing cross cancels there. So that would be negative 144 11ths. We got to subtract 1 from that. And does that equal, we got to do negative 24 11ths plus 5. Let's come up here and do that. Negative 24 over 11 plus 5 over 1. Let's multiply top and bottom by 11. That gives me an 11 on bottom and a 55 on top. And that would be a 31 over 11. And I'm going to put a question mark because we're not sure if it equals. Negative 144 over 11 minus 1. That's going to be negative 144 over 11 minus 1 over 1. Common denominator is going to be 11. Multiply top and bottom by 11. So that's going to be negative 155 over 11. And when you take the absolute value of that, you get positive 155 over 11. So let me just take that away, and I've got to multiply it now by 1/5. Cross cancel leaves you with 1 and 31, and that's going to be 31 11ths, just like this is, so that one also checks out.